there. And I can keep going on. So I can say 8 sides for an octagon, for example. And the biggest side that I know the name of, the biggest shape that I know the name of, is 12-sided, which is a dodecagon. If we look at what's happened there, it has got 12 sides, but what happens when the sprite hits the edge of the area is that it deviates from its path, and so the shape hasn't drawn properly, it hasn't joined up. So what we need to think about is the fact that the more sides we have, because we're always moving forward 100 steps, the more sides we have, the bigger the shape is going to be. So the triangle was quite small, this is a lot bigger, because actually the length of the sides is the same, but if there's more of them, then you're travelling further overall. So we could think about doing a calculation to make sure that the shape stays on the screen, stays within the white area. So if you think about what's happening, so scaling things is a very useful technique in programming and in other areas of life as well. So if you think about what happens, what we want is the more sides we get, so the higher the number of sides, the shorter the distance we want to move. So if you want the number to get smaller as the sides get bigger, well, the way you can make that happen is with a division. So as we divide by a bigger number, the answer will get smaller, won't it? So if we divide by the answer, that will make the sides shorter as the number of sides increases. What number do we pick for the first box? Well, I suppose if we want, that's a bit too big, isn't it? Dodecagon. So if a 10-sided shape might just about fit on. So if we pick a number in the hundreds, so if we divide it by 10, we want it to be roughly the same as it was before. So we could try 1,000. So then a 10-sided shape, we'd be dividing by 10 and give us the length sides of length 100 again. So if we try that now, see what that does for us. How many sides would you like? We'd like 12 sides, please. And there we go. It fits on nicely. So we just move the cat down slightly so it's not quite off the top. So if we try some other sides now, so if we try the triangle again, then that's a much bigger triangle than it was before, isn't it? So, and it doesn't join up quite because the cat was just off the edge there. So maybe the thing to do is make it just slightly smaller, maybe 900 divided by the answer. So we'll try a triangle again. Let's try a square. So each of these things is roughly the same size now, because the more size we've got, the smaller we're making them. Let's try a hexagon. There we go. Let's try the dodecagon again. Positioning. You might want to think about refining your program to position the cat more precisely to begin with. Let's try something a lot bigger. Let's try 36 sides and see what happens there. Okay, so even much bigger numbers where the shape is tending towards a circle still work now that we've scaled them down. So just to recap, what we've done is we've drawn a polygon by repeating. We've thought about the angles we need to calculate, which are the exterior angles, and the total of the exterior angles is always 360. So if we divide 360 by the number of sides, then that works out nicely to give us the angle we need to turn. And we've also looked a bit at how to scale the shape so it stays within the boundary of the screen.